let's talk about magnetism. Whenever you have a moving charge in a magnetic field, you're going to have a magnetic force. And the magnitude of that force is equal to, let's see, it's the strength of the charge, because that kind of makes sense, doesn't it? That the bigger the charge, the greater the force is going to be, times the speed of the charge, times the magnitude of the magnetic field that it is traveling in. And as a matter of fact, when it's moving parallel to the field, it has zero force. It is only when it is moving perpendicular to the field that it has a maximum force. And we're not going to worry about anything in between. Now, sometimes we're going to have a current carrying wire. And that wire will have a current of I. If we look at a differential length L of the wire and a magnetic field B, so say the magnetic field is going into the page, again, it has to be perpendicular, then the force acting on that wire is going to be equal to the current times the length times the magnetic field strength. Let's do a couple of problems. Suppose I have a proton. Protons are positive with a charge of 1.6 times 10 to the negative 19th coulombs. So Q is 1.6 times 10 to the negative 19 coulombs. It's moving east, so its velocity is east. And it experiences a force of 8.8 times 10 to the negative 19 newtons upwards. So F is 8.8 times 10 to the negative 19 newtons, and it's up. So F is up. At this location, the magnetic field has a magnitude of B equals 5.5 times 10 to the negative 5 teslas. Find the speed of the particle. Now, let's see, and the magnetic field is indeed, lost my pen, acting up to the north. Remember, you put north, south, east, west on your paper, and up and down are in relative to your paper. So north, south, east, west, up is out of your paper, down is into your paper. Now, is this right? Put your fingers in the direction of B. Your velocity in the direction of the particle, which is east, and indeed your palm faces up, so your force is up. So yeah, I have my directions correct. So now let's find the speed of the particle. F is equal to Q, B, B. So I'm looking for the velocity. So the velocity is the force divided by the charge times magnetic field. The force is 8 times 10 to the negative 19 newtons. I need my negative sign to be clear there. Now the charge is 1.6 times 10 to the negative 19 coulombs. Having trouble with my negatives today. I can't really see them here. And the magnetic field is 5.5 times 10 to the negative 5 teslas. Now what I recommend you do is multiply straight across. So I have 8 times 10 to the negative 19 divided by, now 1.6 times 10 to the negative 19 times 5.5 times 10 to the negative 5 is equal to 8.8 times 10 to the negative 24. And I guess this is 8.8, isn't it? I'm having trouble writing today. So when I take 8.8 times 10 to the negative 19, and I divide by 8.8 times 10 to the negative 24, I get 1 times 10 to the 5th meters per second. Now I have a proton, again positive, with a charge, Q, of 1.6 times 10 to the negative 19 coulombs, moves perpendicularly to a magnetic field that has magnitude B equal to 4.20 times 10 to the negative 2 teslas. What is the speed if the force, this is is 2.4 times 10 to the negative 14 newtons. This is the same sort of problem. We're looking for V. F equals Q, V, B. So the velocity is the force divided by QB. The force is 2.4 times 10 to the negative 14 newtons divided by the charge, which is 1.6 times 10 to the negative 19 coulombs. The magnetic field is 4.2 times 10 to the negative 2 teslas. So this is 2.4 times 10 to the negative 14 newtons divided by, now multiply 1.6 times 10 to the negative 19 times 4.2 times 10 to the negative 2, and you get 6.72 times 10 to the negative 21. All right, when you divide that by 2.4 times 10 to the negative 14, you get 3.5714 times 10 to the 6 meters per second. Let's check our directions. Protons, oh, I don't really have directions, so don't worry about directions. But in this unit, we're always worried about directions, so make sure you check. A proton with charge 1.6 times 10 to the negative 19 coulombs. All right? So Q is 1.6 times 10 to the negative 19 coulombs. Traveling to the right along the x-axis, so V is east. Where there's a magnetic field, B is 2.5 teslas directed upwards. Okay, so it's going north. If the proton experiences a force F of 3.2 times 10 to the negative 12 newtons, find the speed of the proton. Now, first of all, I know it doesn't ask us, but let's find the direction. Put your fingers north in the direction of B. So this is your fingers, and this is your thumb. Now, what direction is your palm facing? And of course, it's facing up. So, we know that the force is facing up. It didn't tell us that, but you could figure it out. So, F equals Q, V, B. So, V is F divided by QB. The force is 3.2 times 10 to the negative 12 divided by 1.6 times 10 to the negative 19 times 2.5. Now going to multiply this across, 3.2 times 10 to the negative 12. Now, 1.6 times 10 to the negative 19 times 2.5 gives me 4 times 10 to the negative 19. So 3.2 times 10 to the negative 12 divided by 4 times 10 to the negative 19 gives me, let's see, 8 times 10 to the 6 meters per second. If an electron, okay, now everything we do is going to be negative. With a charge of 1.6 times 10 to the negative 19 coulombs, experiences a downward force of 2 times 10 to the negative 14 newtons, while traveling in a magnetic field B of 8.3 times 10 to the negative 2 teslas, west. So B is west. And the force is down. So that's the force. What is the direction and magnitude of the velocity? Clearly the velocity is either going to be north or south. Put your fingers in the direction of B and the force down. If you do that, you'll see your thumb points south. But this is an electron. Because it's an electron, you know the velocity has to be north. Now, let's find the velocity. F equals Q V B. So V is F divided by QB. We've done this problem, haven't we? The force is 2 times 10 to the negative 14th newtons divided by 1.6 times 10 to the negative 19. Do not worry about the sign. B is 8.3 times 10 to the negative 2 Teslas. Now, this is 2 times 10 to the negative 14 divided by, go on and do the calculation. 1.6 times 10 to the negative 19 times 8.3 times 10 to the negative 2 gives you 1.328 times 10 to the negative 20. Oh, that's hard to see, isn't it? That's a 2, 0. Now divide that into 2 times 10 to the negative 14, and you get a velocity of 1.506 times 10 to the 6 meters per second. And we've already found that the direction is north. North is the top of the page, south is the bottom of the page, east is right, west is left. A uniform magnetic field points north. So B equals 1.5 Teslas, and B points north. If an electron with a charge of 1.6 times 10 to the negative 19 coulombs, so Q is 1.6 times 10 to the negative 19 coulombs. And because it's an electron, I'm going to circle electron. I know no matter what I do, I'm going to flip whatever my last answer is. Moves vertically downward, so velocity is downward with a speed of 2.5 times 10 to the 7th meters per second through the field. What force must be acting on it? Well, let's find the force. F is Q, B, B. So it's 1.6 times 10 to the negative 19. It's moving at 2.5 times 10 to the 7th meters per second. And B is 1.5. So we get an answer of 6 times 10 to the negative 12 newtons. Now let's find the direction. B is to the north. North is top of the page. South is bottom of the page. East, west. Oops, west. Now, B is north. V is moving downward. So flip your hand over so it's pointing downward. Now you're going to see, put your thumb down so it's pointing downward. So B is north to the top of the page. Your thumb is downward. You're going to see your palm faces east. That's the direction of the force. But because it's an electron, you flip it. So the force is pointing, of course, west. Now you know I'm going to give you an electron on the test. I'm just like that. Now, a proton with charge Q equals 1.6 times 10 to the negative 19 coulombs moves straight upwards away from the ground. So it's moving upward, so that's V. Through a uniform magnetic field that points from east to west. So B goes from east to west and has a magnitude of 2.5 Teslas. If the proton moves at the speed of 1.5 times 10 to the 7th meters per second, what's the force? Well, F is Q, V, B. So it's 1.6 times 10 to the negative 19 times V, which is 1.5 times 10 to the 7th times 2.5. So this is 6.0 times 10 to the negative 12 newtons. Now what about the direction? Put your fingers in the direction of B and put your thumb, oh, I'm losing my pen here, thumb in the direction of V. So B is pointing to west and your thumb is pointing up. Now you're going to see that your palm is facing south. Your palm is facing the bottom of the page. Because it's a proton, that is the correct direction. So your answer is south. Now I have an alpha particle. Now an alpha particle is a nucleus of a helium atom. Nuclei are always positive. So Q equals 3.2 times 10 to the negative 19 coulombs. And has a speed of 5.5 times 10 to the 7th meters per second. And it's at right angles to a magnetic field. It has a force, F, of 1.5 times 10 to the negative 14 newtons. Losing my negative sign. What's the magnetic field? F equals QVB. Now, I didn't give you direction, so you cannot compute the actual direction. B is F divided by QV. The force is 1.5 times 10 to the negative 14 newtons. The velocity is 5.5 times 10 to the 7th. And that's I forgot the charge. 3.2 times 10 to the negative 19. It doesn't matter which order you put them in. So this is going to be 1.5 times 10 to the negative 14. Now multiply these two numbers together. All right? 5.5 times 10. Oops. Let me clear that. 5.5 times 10 to the 7th times 3.2 times 10 to the negative 19 is 1.76 times 10 to the negative 11. Now divide 1.5 times 10 to the negative 14 by 1.76 times 10 to the negative 11, and you get an answer of 8.527 times 10 to the negative 4 Teslas. That's enough sig figs. A wire 36 meters long, so L is 36 meters, carries a current of 22 amps, and the current is from east to west, so the current is this way. If the maximum force exerted on the wire is pointed downward, so F is downward, and has a magnitude, oh sorry, my board is a little crooked, F equals 4 times 10 to the negative 2 newtons. Find the magnitude and direction of the field at this location. So I know in this case F is ILB, bilb. So B is F divided by LIL. F is 4 times 10 to the negative 2. The current is 22 amps. And L is 36 meters. So this is going to be 4 times 10 to the negative 2 divided by, now you want to do 22 times 36, and that gives you 792. 4 times 10 to the negative 2 divided by 792 is 5.05 times 10 to the negative 5 Teslas. Now, let's find the direction. Put your thumb in the direction of the current, which is going to west, to the left of your page. The force, which is your palm, all right, is into the page. Is that right? Let me check. It goes from east to west. Maximum force is downward. So the force, your palm is downward. Find the magnetic field. I see that my magnetic field is pointing north. My fingers are pointing north, so that's B. So that's definitely from south to north. So I is your thumb, F is your palm, and B are your fingers. Now, a 6-meter wire, so L is 6 meters, carries a current of 7 amps toward the east. So I is 7 amps, and I is going east. A magnetic force, F, of 7 times 10 to the negative 6 newtons acts on the wire upward. So F is upward. Find the magnetic field producing this. So F equals IL B. So B is F divided by IL. So the force is 7 times 10 to the negative 6 newtons. I is 7 amps, and L is 6 meters. Multiply this out, you get 1.667 times 10 to the negative 7 Teslas. Let's figure out the direction. The force is up, current is to the right, and you'll see that your fingers are pointing to the top of the page. So that is B. This is your fingers. I is your thumb. And F is your palm. Now, I have a wire 1 meter long. Experiences a magnetic force, F equals 0.5 newtons, due to a perpendicular magnetic field. If the wire carries a current of I equals 10 amps, what's the magnetic field? F equals ILB. So B is F divided by IL. F is 0.5, I is 10, L is 1. So multiply this across. This is 5.5 divided by 10, 0.05 Teslas. Magnetic force on a straight 0.15 meter segment, so L is 0.15 meters, carrying a current I of 4.5 amps, is 1 newton. F equals 1 newton. What is the magnitude of the magnetic field perpendicular to the wire? F equals ILB. So B is F divided by IL. The force is 1 newton. I is 4.5 times L, which is 0.15. Go on and multiply this out. This is going to be 1. Now, 4.5 times 0.15 is 0.675. Now, 1 divided by 0.675 is 1.48 Teslas. The magnetic force acting along a wire that is perpendicular to a 1.5 Tesla, so B is 1.5 Tesla. Uniform magnetic field is 4.4 newtons, so F equals 4.4 newtons. If the current I is 5.0 amps, what is the length of the wire? So F equals ILB. So I'm going to solve this for L by dividing by IB. So L is F divided by IB. The force is 4.4 newtons. I is 5 amps. And B is 1.5 Teslas. So this will be 4.4 divided by, go ahead and multiply this out. 5 times 1.5 is 7.5. Now 4.4 divided by 7.5 gives you 0.586667 meters. That's close enough to 5.9 meters. A particle with charge 0.03 coulombs, so Q, is 0.030 coulombs, experiences a magnetic force, F, of 1.5 newtons. When moving at right angles to a magnetic field, if the speed, V, is 620 meters per second, what's the magnetic field the particle passes through? F equals Q, V, B. So B is F divided by Q, V. The force is 1.5 divided by 0.03, and the velocity is 620. So this is 1.5 divided by, now, 0.03 times 620 is 18.6. So 1.5 divided by 18.6 is, let's see, 1.5 divided by 18.6. I'm getting 0.0806 Teslas.